Hi friends, how are you all? So now I think it is time for us to start our discussion in class 11 and 12 mathematics. In this video we will be discussing the topic set. Okay, this is the basic in many branches of mathematics including calculus. So before we go into the topic, let me make a warm request to you. If you are visiting my channel for the very first time, please subscribe to my channel. Also like my videos, and if you have any doubts or opinions or feedback, feel free to comment and let me know. Okay, so now let us start with the topic set. Now when you hear the word set, what does it remind you? Something set, something like a collection of something, right? Something, group. That's what we call set, right? A set of people. That's what we call. So, but let us now focus what it holds in mathematical terms. Okay, so first, basics. What are the basics of a set? First of all, what are the two characteristics we need for something to be called a set? First one is that it is a collection of objects. Objects or numbers or anything. Object, it can be anything, collection of anything. Okay, if it can be a collection of people, it can be a collection of clothes, it can be a collection of tables, it can be a collection of chairs, it can be a collection of computers, it can be a collection of pens, it can be a collection of pencils. But can every collection be termed a set? There is one more characteristic which determines which collection should be termed as a set in mathematical terms. And the second characteristic is that it should be well defined. And what do you mean by this well defined? It is, I don't, by well defined, it doesn't mean that we should have some English definition for each of the things. Naturally, that can be done. In the thing is, what do we mean by well defined? Let me tell you an example. Let's consider two sets. Set of natural numbers less than or equal to 5. Okay, this is one set. Then the second set is of the set of all intelligent students in a class. How do you, what the difference between these two? Set of natural numbers less than or equal to 5. It is actually well defined because we can identify clearly when you see a thing, when you see something, you can clearly tell whether it belongs to the set or not. Can we? Because any number, whenever you see 1, 2, 3, 4, and 5. These 5 numbers are those that belong to the set. Right? Whenever you see these 5 yourself, yes, this belongs to the set. But whenever you see any other thing, we can never tell that belongs to the set. So we can identify clearly whenever upon seeing an item, upon knowing the characteristics of an item, we can clearly tell whether it belongs to the set or not. Now, set of all intelligent students in a class. Tell me, is it when you are seeing a student, can you tell whether he is intelligent? Might be you tell yes, because it's a general opinion. Few students are intelligent. But let me tell you an example. There are two teachers. Okay, one is a maths teacher and one is an English teacher. Okay, now there is one student. There is one student. What this student does, the student studies mathematics well, but he is very poor in English. So the mathematics teacher will tell, wow, this boy is very intelligent or this girl is very intelligent. But the English teacher will tell, oh Lord, this student is very poor, very not at all intelligent. So that differs from person to person. Therefore, Intelligence is not a characteristic that is well defined. It can depend from person to person. Depending on your opinion, the people characteristics will also differ. So this is not well defined. Such characters like intelligent or something are not well defined. But now I tell you, instead of intelligent, if we say in the same class, a set of students whose average score in last exam is greater than 70%. This we can calculate from the marks of the students, and therefore upon calculation of the average mark, we can tell whether the student is belonging to the set or not. Right. So this is the characteristic of well definition. Okay. Now how do we express or notate set? There are many things. First 3 points. In expression or writing expression, let's write expression. There are 3 points. First of all the set names are denoted by capital letters like A, B, C, and all the elements of the set are given by small letters A, B, C. Say for instance, a set of for the first 4 letters of English alphabet. So A, let's read A is the set of, this is the notation for a set. This is called set braces, and inside this, if we write some things, those things are element of this set. Okay, A, B, C, D. Here when you see, and we close it by set braces also. This is set braces. Okay, A is what? The name of the set, and the elements of the set are A, B, C, D. My name is Vijay and my elements are my hand, my eyes, my ears, my nose, and all these things. So Vijay I write it in capital letters, and all these things I write in small letters. This is how we express a set. Then how do we write the elements? Let's take an example. Set of all natural numbers less than or equal to 10. Natural numbers less than or equal to 10. Now there is 2 ways we can write this. Like we can write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right. This method, when we list out all the elements of a set, is called the roster form of set notation. But if the set is too much, infinite, can we notate it like this? Yes, we can, because let us take the set of all odd numbers. Set of all odd numbers, we can just give select 1, 3, 5, 7, 9, and we can put some dots. And what does this mean? It is clearly understood that is the set of all odd numbers, because the only common property possessed by these 5 numbers is that they are odd numbers. So this is the roster form. Now, there's another form. We can write the same set as the set of x, set of all x, such that x less than or equal to 10 and x element of n. And what of the set of all x? The variable x can take any values. I have already told you variables can take any value. So that x is less than or equal to 10. So definitely it is not going to be greater than or equal to 10, and x element of the set of natural numbers. It will naturally come to this set. This method is called the set builder form. We are just writing a rule which shows or which depicts the property which is commonly possessed by elements of the set. This is how we notate, we write the set. Okay. That is, set names are given in capital letters and the elements in small letters, number 1. And there are 2 forms, listing out all the elements or giving some elements and putting dot 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 is the roster form. And or if you write the rule that determines which elements are to be included in the set, and which gives the unique property possessed by elements of this set is called the set builder form of expressing a set. Okay, now after this we need to study a few things. First of all, subset and power set. Subset and power set. See, let us take the set 1, 2 and 3. Okay, this is set 1, 2 and 1, 2, 3. There are only 3 elements in the set 1, 2, 3. What is this set? In roster form it is this, and in set builder form it is x, set of all x such that x less than or equal to 3 and x element of f. This is the set builder form. Now I am defining another set. What is set 1? Okay, what can you tell? X is the set of all natural numbers such that x less than or equal to 1 and x element of f. There is only one element. Now, can you tell me whether this set is included in this set? Whether the set 1, 2, 3 includes the set 1? Naturally, yes. Naturally, yes. So, if this is A and this is B, this is A and this is B, we say B is included in A or B is subset of A. This is the notation for subset. That is, a subset of a given set is the set that contains some or all the elements of the given set but nothing more. It can contain the sum of the elements and not SUM sum. SOM means sum. Okay. Some elements of the set, or it can contain even all the elements of the given set, but it will never contain any element that is not in the set. Okay. This is B subset of A. Now with this subset, I include, just put a mark down, if then B is subset of or equal to A. Okay, it is pure subset and this is impure subset, because in pure subset B cannot have all the elements of A. But in this form of subset, it can have all the elements of A. It is just some new way of expression, that's all, nothing new. Now, there are many subsets to the given set. A set consisting of all the subset of a given set is called the power set. Now we took the set A is the set of set 1, 2 and 3, right? Now I am writing another set V. This is the set. Now I am writing like set 1. Before that let me introduce you the null set. A set that has no elements, null means 0. A set that has no elements is called the null set. Okay, let me tell you. Let me define X as the set of all numbers such that X not element of C. At present, the maximum system we know is the complex number system. I will tell you about that later. We have a chapter in complex numbers coming up. If X is not an element of the set of complex numbers, then there is no number now we know. So this set has no elements at all. Okay, so such a set is called a null set, which has no elements. Okay. So now let us first I will write the null set. Then I will put a comma and write I will set 1, set 2. These are all subset of this set, okay. Set 3, set 1, 2, set 2, 3, set 1, 3, and finally the last subset set 1, 2, 3. This big set is called the power set of this set because it contains all the subset of this particular set. Okay, whether they are the null set or they are equal to the given set. It contains all the subsets, whether they are proper or improper or anything, they are subset of the given set, and a collection of subsets of the given set is called a power set. There is one important property that the null set and the given set will always be the subset of the given set. The null set and the given set will always give the subset of given set, and the null set will always be the subset of any set. Okay, these are the two properties we need to keep in mind. So whenever you are writing a power set, first you write the null set. Then you take each element and write it as a given set. What is an element? Anything that belongs to any individual thing that belongs to the set is called an element. So write one element each, then write two each, then three each, and so on. Okay, this will give the power set. Now we learned subset and the power set. Now let us learn the universal set. Any set that contains this given set that can be said to encompass the given set. Okay, universal. It is see, and it should be some realistic. Okay, if you tell me the universe set has all things in the universe, you can't tell that. It should be some realistic. Like, let me tell you, if I sell the set 1, 2, 3, then you can put the in universe set as anything. Okay, set 1, 2, 3. You can put the universe set as anything. You can be equal to n, the set of all natural numbers, though it is too high. Even you can put n, it is okay. Or you can put the set of all x such that x less than or equal to 10 and x element of n. This is also a universal set of this set. It is not necessary that the universal set should have this much elements or anything, but that universal set should contain the given set and at least a few other elements. Okay, it should not be just the given set, it should have some more elements and nothing less of the given set. The subset and the universal set are opposite. The subset has at most all the elements of the given set and nothing more. But the universal set should have at least all the elements of the given set and something more, at least something more. So this is the given set. Now, this is 1, 2, 3, and let's take this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, let me give you a set B, that is 4, 5, 6, 7, 8, 9, and 10. What is the relationship between these two? This A, this U, and this B. Let me erase this U. This U is not required. What is the relationship between them? A has 1, 2, 3, and U has 1 to 10, right? But what is the B? B has all the elements that are not in A but they are in U. Those elements of U that are not in A will be there in B. Such a set is called the complement of the given set. It can be denoted by C or dash or anything. Okay, so B here, B is A complement or A complement. Okay, complement is the set that contains all the elements of the given universal set, but it does not contain any element of the given set. It contains those elements of the universal set that are not belonging to the given set. This is the case of complement. So I think you have got a basic introduction to the notion of sets. So in this session we first saw what is a set, then we saw how to express set, the roster form, set builder form, then we saw the case of subset, proper subset, improper subset, then we saw the power set, null set, universal set, and the complement. So this will be with this first session in the theory. So we will meet again in the next session. So till then, have a great time. Bye bye.